Thank you very much. Good afternoon. Good day, everybody. Good day to you, Dr. Ho.
Thank
I
you.
have. I am very happy to introduce the present speaker, Professor Dr. Ho. He is Vice President, Academic and Industry Internationalization and Professor of Computer Science in Multimedia University, Malaysia. He is Faculty of Computing and Informatics since 2014 and was VP since August 2018. Joined the MMU in 1999. He is Dean of the Faculty from 2008 to 2018. He is founding director of Research Institute for Digital Enterprise. His expert area is data science. Hello, mute other people. His expert area is data science and computer science education. He was affiliated member of Malaysian National Big Data Analytics Task Force and National ICT Talent Task Force. Professor Ho has led network intelligence and analytics research program at MMU. He is research fellow at the Yangtze Delta Region Institute of the University of China. Professor Ho leads for MMU's Smart Campus project. He has won award for outstanding contribution to education in 2015, Educator and Excellence Award, won gold medal at 2020 international competition in Canada. With this, I request Dr. Ho to take over the platform. Thank you, sir.
Okay, thank you, Dr. Sambandan. Just let me share my slides. Can you see my slides? Is it coming out on screen?
Yes, so we could see the slides, but it's not in the slideshow mode.
Okay, so just okay. Is it better now?
Yes, sir. Yes, sir.
Okay, so thank you very much. I would like to take this opportunity to thank KCG College for the kind invitation, especially Dr. Sambandan, who has been communicating via email and so on. And I'm very happy to give a talk and share my experience. I noticed that this series of talk is actually centered around cybersecurity and also power grid and so on. But what I would like to actually do today is to give a more general approach to the fourth industrial revolution, to share the philosophy at our university, which is looking for research and development that actually benefits the society. So a bit, yeah. So I'm at the moment I'm an administrator. I'm the VP for academic at Multimedia University. But at the same time, I also serve the Faculty of Computing Informatics as a professor, and I also do some work in some research work in China. I'm a research fellow at the one of the Tsinghua University Institute in Zhejiang in China. So I have visited India, many times, and of course, because of the COVID-19 situation, I'm unable to visit India this year around. In fact, at this point, uh, the government of Malaysia is not allowing, at this point, anybody to go overseas. So we have to stay at home in the country here. But just let me share with you some of the pictures that I took in my recent trips, past few years to India. So this is, of course, um, I visited Mysore in 2017 to give a keynote speech at one of the conferences as well. Of course, the background is the Mysore Palace. So this was 3 years ago. And I believe this is nearer, this is closer to Chennai, I believe. This is the Mahabalipuram. I just visited this last year in April. I visited a few friends as well. It's a very, very nice place. And this is a bit further away in, this is further away in Kany Palace, which is the highland areas. So I visited here in March 2018. So, I'm very happy to, give talks and so on. And when I received this invitation, yeah, of course, I look forward to giving this talk today. But before I go on to the talk, I think it is my obligation to give a short sharing, maybe just a few minutes about my university here. We are, the name of our university is Multimedia University. We are a private university. In fact, we are the first private and we are the first and largest private university in Malaysia, established in year 1996. If you look at the screen, that is, we have 3 campuses. So what you see on screen is the campus where my office is located. It is in a technology park called Cyberjaya. So this city of Cyberjaya is just 20 minutes from the international airport. So if you are here in Malaysia at the international airports, do drop me a message. You can come to visit this campus in Cyberjaya. We essentially, Multimedia University in Malaysia, we have about 13,000 students. We have 3 campuses. The one that you see in the middle, my office is here on the 2nd floor. This is the management building at our Cyberjaya campus. We also have another campus in Malacca, which is in the state of Malacca, which is 2 hours down south from the capital of Kuala Lumpur. So Malacca is a very nice place. It has a few UNESCO World Heritage sites. So it's a very nice place to have a university and also to have sightseeing. Our latest and 3rd campus is in the state of Johor, the southern state of Johor. So if you don't know Johor, Johor is just about 30 minutes up north from Singapore. So if you drive from Singapore, in about 30 minutes, you will reach our campus here in Johor. This campus here, we run only one program, which is our cinematic arts program. So we work with the University of Southern California in the States. That is the actually top film school in the world, University of Southern California, and we run the cinematic arts program in collaboration with USC in the US. So this is a very brief snapshot of our MMU's 3 campuses in Malaysia. Right. So the context of today's talk is basically just to share the research philosophy at MMU is that we want both our staff and also our students to do research which impact the lives of communities around us, the life of people in the country and in the region. So therefore, it is, what shall I say, it is a requirement for our researchers, both staff and students, to align their research work and against the United Nations Sustainable Development Goals. We have 17 altogether. I believe that you are aware of this. So what we want to do is that each research proposal that our staff members submit, we want to see how they are aligned to this UN Sustainable Goals. Okay. Okay, I don't know. Someone just started to share. Should I just share again, or not sure? Somebody just.
Sir, you have to share again, sir.
Yeah. Okay.
Yes, sir. Now it's coming. Now it's coming, sir.
Okay. All right. So let me move to the next. Okay. So what I want to share with you is actually
in full mode view.
It's full actually.
Sir,
actually I'm looking at the full screen.
Yes.
Are you able to see the full screen?
Now, sir, yes, sir.
Now, is it okay
This is
now?
the first. Is okay, sir. Now.
Okay, yeah. Okay. What I
Once
want
again,
to,
into PPT mode.
is it in a slideshow mode now? Can you see it?
Yes, sir. Yes, sir.
Okay. What I want to share in my talk today with the audience is three research projects which we have completed, and these are the three projects that what I would say good examples of research that impact the lives of people, local community, for example. Yeah. So this is so whatever I even we talk about the fourth industrial revolution and so on. So I believe that technology and whatever we develop, using this technology should be there to benefit people. It should not just be research projects that stay in the lab where you get publications and so on. So this is a philosophy that I hold very closely, and I would like to share with you today three of such projects which make use of technologies like IoT, communications, data analytics, and so on. So the first project which I want to share briefly is the geohazard risk management. In Malaysia itself, we have two main natural disasters that always hit us every year. The first one is landslide, and the second one is flood. So I will share some of the things that we are doing to help the community impacted by flood and also landslide. The second project that I would like to share is actually around precision agriculture. What you see here on screen is actually a cocoa tree. Malaysia used to be one of the largest producer and also exporter of cocoa in the world, but in the past 10 to 15 years, the output from the cocoa sector has actually dropped. So we have a team of scientists who actually work with cocoa farmers, to implement precision agriculture to help cocoa farmers cut down their cost of planting and so on. So I'll share a bit about this later on. Thirdly, more towards the urban application, we have I will share with you what my team has done in terms of implementing what we call the smart toilet from the viewpoint of facility management. Yeah, how can we use the fourth IR industrial revolution technology to manage and also to cut down and optimize the cost of managing, for example, toilets. So these are the three things that I would like to share. These are three projects that we have completed. But before that, what are the technology mega trends that we are going through right now? Of course, first, as I think you will know, because you are either working in an engineering college or you are an engineering student. So, Internet of Things is, it's already here. We don't even talk about this anymore because, we are using it already in our everyday life. But of course, the degree to which we use such technologies may differ. But I believe the very simple example will be each of us will have a handphone, right? Each of us will have a mobile phone, and this mobile phone is actually a I would call it a multi-sensory device because, it tells everything about, about yourself. Yeah? And of course, we have many more. So this is here to stay. And with the Internet of Things, coming on and so on, we have what we call datafication. So everything is, everything these days is generating, data. When you start your car engine, when you drive your car, you are generating data. When you go into the supermarket, you are generating data. And because of this COVID-19 situation in Malaysia now, I'm also across the world. Wherever we go, for example, every time I step into a shop, I have to check in. I have to scan a QR code and I have to check in. into the government system saying that at this point in time, I am here now in this shop. So you imagine the amount of data which is generated these days, right? So this is the second thing that we can take advantage of course, is datafication. Of course, the third is of course AI and automation. Uh, I think many examples of this. I Before the COVID-19 pandemic, I visited China for a while. I stayed in China for about 1 month in last December, and thankfully I managed to get out of China and come back to Malaysia before they locked down everything. So, we see more and more this AI automation going on. For example, in China itself, whenever I drive into a shopping complex or a parking complex, well, what they do there is actually, they have this camera system that automatically recognizes your car plate, and they are able to. So when I go in, I don't have to wind down my window, take a parking ticket or something like that. I just drive in, and when I want to get out of the car park, I don't have. Again, they use a system, the computer vision system, to actually look at your car plate, and they can automatically charge my e-wallet in China. Of course, this is in China, but in Malaysia we don't have this system yet. So the degree of application of AI and automation differs from place to place, but these are the things that we are already implementing across the world. So this is another key trend that we see in the fourth industrial revolution. The fourth one is, of course, blockchain. Many countries in the world are looking at digital currency. I'm not sure about India, but for Malaysia, we are picking up digital currency, assetization, tokenization of assets, and so on. In fact, for my university last year, in the year 2019, we ran in the country. In the country, we ran the first electronic election for our student representative council on the blockchain system. Right? So this is the first that we have implemented in the country last year. And again, of course, this is a decentralized control and data. 3D printing, I would say, this is additive manufacturing. We have in the university, we have 3D printing machines for students to use, for them to, come up with products and so on. And of course, one of the key technology that will be mainstream soon is 5G. Of course, we are very excited because Multimedia University is the subsidiary company of Telecom Malaysia, and we are the largest telecommunications company in Malaysia, and we will be rolling out 5G soon. And we are positioning ourselves as one of the key research hub for 5G technology and applications in the country. So, of course, we welcome all sorts of collaboration. In fact, in my campus in Cyberjaya, we already have a set of 5G equipment, and we are actually transmitting 5G signal now in the university for experimentation, not for services. So this is currently going on in the university. Right. So those are the key trends that we see happening, and we should leverage these key technologies to see how we can improve the lives and make lives easier for our society, for our community. Let me now go into just a very brief sharing on the three projects that I mentioned earlier. When we started these three projects, our aim has been always one and the same, which is we ask ourselves, how can we use technology to benefit and to improve the lives of the society around us? So the first project that I would like to share is actually on managing geohazard as in natural hazards in Malaysia. Right. The first project is actually quite a large project. We have completed it last year or a couple of years back. This was a project which is collaboration from many partners. In Malaysia, we have a few partners. We are here, MMU. We have our Energy University. We have our Science University. In Japan, we collaborate with University of Tokyo, Chiba University, of course, with the National Research Institute for Earth Science and Disaster Prevention with Ibaraki, a few other universities which I did not put here, and this project was sponsored by the Japan International Cooperation Agency or JICA. Now, a bit of a background. The first picture on the top is actually a real picture. It is at a village called Sungai Ruil. That means it's a village in one of the highlands, one of the popular highlands in Malaysia, a good tourist destination. It's called Cameron Highlands. If you have been to Malaysia, probably you may have visited this place. If you look closely at the image, the one that I'm pointing here, you can see that actually a landslide has occurred, right? If you look at the hill here and you look at an empty space here, this is the one where the slope has failed. And in 2011, the landslide occurred and it flattened, I think, 3 or 4 houses, killing about 10 to 11 people, right? And ever since, the government has relocated this village to a nearby place. In the bottom image in 2014, this is one of the biggest floods in the history of the country that hit our East Coast state. The name of the state is Kelantan in 2014. And when we started off on this project, whatever previous models that we built for the river basin actually does not fit anymore, because after this flood came, we had to go back to the drawing board and look at how we can recalibrate the flood models that we have. So these are 2 examples. Of course, we have floods every year in this same place. Landslides happen every year as well, because we have very large amount of rainfalls. So I think this picture is a good picture to represent what we actually do in the project. What I will share more in this talk is actually on the landslide part, but not the flood part. But this is the entire schematic of the project, which we have done and we have completed and we have delivered to the authorities. So what we did was that we selected some sites on the what we call this expressway that we have connecting the east to the west of the Peninsular Malaysia. We selected a couple of high-risk sites for landslides to monitor. Okay, so we plant all sensors. For example, the sensor to measure the groundwater, the inclination of the slope, and so on. Okay, so this project is a good example of a multidisciplinary project. I'm trained as a computer scientist, but on this team we have mechanical engineers, we have civil engineers, we have geotechnical engineers, and we also have social scientists who come and work together. Yeah, because to manage the technology part and also to manage the various stakeholders, for example, the government, the community, and so on. So the data that we have from the sensors are sent via telemetry systems into the database. And from the river basin, again, we send the data to a different database. What we actually did some research on is actually the middle piece here, where from the landslide data, we actually created the landslide prediction engine. Landslide is to predict landslide is actually very challenging because you don't really know when the slope will fail. Yeah? It could rain for 5 hours and the slope will still be okay. But another time, at another slope, it may just rain for half an hour and the slope will fail and you have the landslide. So this is a key challenge, which basically means that the landslide model that we built for a particular slope, let's say the first slope here, may not be directly transferable to another slope. So this is one of the key research challenge that we have. And from this data also, we built a large-scale hazard map of the entire country. Of course, Malaysia is not as large as India, so it's not as complex to build a hazard map. Just requires some statistical analysis. And for the flood prediction engine, we work with our Japanese partners to actually come up with simulation and simulation engine and so on. And at the end of the day, we have actually two systems which is able to predict and forecast the inundation map, meaning that if a flood is going to happen, the tool can tell us, which part of the river will overflow its bank, and the inundation map will tell us, which area will be covered by water and for how deep and for how long. So at the end, we have that tool which actually we pass on to the local authorities who then can actually use it. So this is on the the landslide and flood analytics. Now, what is equally also important is in the yellow box, because the one that's on this orange box here is actually mainly technology, right? So these are all the engineers are actually working here. But when you come to the yellow boxes, because we need to benefit the end users, the authorities, society, and so on. So we have developed, so some software engineers has worked with some social scientists to develop the early warning communication systems. Okay, you see, the challenge is that a lot of this flood and landslide actually occurs in the rural area. So in the rural area, the education level is not as high as urban area. So the way that we have to educate and communicate to them, to these rural areas, will be very different. So, we need to build in a separate approach. Because I just give you an example, in rural areas, especially the indigenous people, if you ask them to read, let's say, a rain gauge, which tells how many millimeters of rain has come, well, they cannot read the meter because most of them cannot count beyond maybe number 5 or number 6. You see, they can count from 1, 2, 3, 4, 5, but beyond that, they cannot count. So this is something, we work with social scientists to actually see how we can educate these, these people, to run away, for example, to evacuate when the flood comes, or the signs of floods. We also develop community education content. We go to schools in the rural area to educate the children on, the dangers and the characteristics of, flood and also landslide and what to look out for. So this is the entire picture of the project. But what I want to share is, of course, if I just talk very high level like that, is not really fun. But let me show what some of our groups have done. So this is not only my work, this is a work of a large group of people in the university and also our partners. So I'm going to zoom in on a very specific study on actually looking at slope properties, okay? And we work with ground sensors, we work with radar data, satellite, and also images captured by drones. Before that, the picture that you actually see here is actually, you see, when you study landslide, this is, we want to study we can do simulation, whether it is, finite element simulation or whatever, you can do it. But what we actually did in this project is, this picture is captured in Japan, nationally in Tsukuba, which is about 30 minutes by train from Tokyo. This is at the National Institute of Earth Science and Disaster Prevention. So this is what we call the large-scale landslide simulation. So what we did was that if you look at this this whole rail here, this is we constructed an artificial slope using earth, which imported from the study site. Okay, and you can see a lot of researchers here. I'm also here. I'm the one taking this picture, by the way. So we have some monitor. We plant all sorts of sensors inside this slope, and if you can see the roof, the roof has a lot of rail where we can actually simulate rainfall. So you can adjust the velocity and also the volume of the rainfall onto the slope. And what we did was we wanted to capture the data on the changes of the properties of the slope here and also of the soil as the rain actually hits it, right? And you can see that this is a control station here where all the data is going to be logged. And we started the rain at a very huge amount. And after waiting for about 1.5 days, yeah, the slope finally failed. Okay, and we managed to collect some data from here. Of course, this is an experiment which is very difficult to replicate. In fact, within a year, we can only run one experiment because the facility is very widely used and the cost of building this is quite high. I think to build this with everything inside, you know, it costs about 100,000 USD just to make this one experiment. But you know, the data collector, of course, is very useful. So this is looking at the real scale, you know, for real scale study of the slope. Okay, now the next one is that some of the interesting thing that our remote sensing group did in Cameron Highlands. Essentially, this is a name of the mountain. It's called yeah, Gunung means is a Malay word for mountain. So you can see that this is you can see that on the right picture, the landslide has actually occurred. This is a big landslide. This is a tall mountain, and what happens is that actually there is a highway, there is an expressway running through the mountains. This is the one that I'm pointing to. So what the groups wanted to do was they wanted to come up with a digital elevation model of the entire place. So of course you can do many things. You can actually do laser scanning. You can use LiDAR to scan, but it's quite an expensive way to do things. So you know what our group did was that we fly a drone around this area and capture hundreds and thousands of images, which we then reconstruct using some image processing to come up with the 3D features of the slope, of the angle, inclination, and so on of this place. Okay. Of course, this is a study done many years ago. At that time, there was just you know, DJI Phantom 2, but of course now, you know, we have many more options. So DEM stands for the digital elevation model. Actually, in terms of this is an interesting problem, because from this particular problem, there are many sort of research problems that you can do. For those who are working in computer science, data storage and management, you can imagine the amount of data that you are storing. You know, so you can look into some of the aspects. You know, we need to fuse data, you know, in many ways, from to fuse them with satellite data, radar data, and so on. Right? So many interesting challenges and also research aspects that you can do from this. So this is the you can see the flight path, the blue squares, the small blue squares. These are the this is the flight path of the UAV, which took hundreds of images over the study area. And after we do auto correction of the photo, I mean, auto correction is needed because when you take a photo from the sky, of course the Earth's surface is a curve. It's not you know, a flat plane. So we need to do auto photo correction for those kind of things so that you can get a flat photo. So what is you see in bright colors here is actually the photos which have been stitched together. I think this is 300 plus photo. Of course, we are not only interested in the photo, we are interested in what we can derive from the photo, the 3D characteristics of that particular study area. This is a closer photo. You can see this is the highway. Landslide has already occurred on the bottom part of the slope, but you know, a more dangerous place is actually also on the top part of the slope. Right. This is a bit higher resolution from 700 plus photos, and ultimately what we wanted to get is actually this one, the digital elevation model of the mountain. So you can see that, you know, you can see the depth by the colors and so on. And with this map, actually, the team can actually look at, do some further simulation and study on the slope in terms of the likelihood and so on of a landslide. Okay, and this will also help the authority. We provide the authority with this sort of input as well. So this this group is mainly done. This work is mainly done by Professor Koo from our Malacca campus and Dr. Lim from our Malacca campus. This is our main remote sensing group in the university. Okay. Just let me show you. Of course, this one is for, this is what you see on the screen. This DEM is not for the ordinary folks. These are basically for engineers to work with. But what we actually do also is that we have a live system which is connected live. So what we can do is that we can go, the authority or the engineer in charge can actually go into the system and they can actually get a live feed of the measurements. So what you see, the bubbles on the screen here, this is the map of Peninsular Malaysia, and these are the locations for this particular research project. These are the particular location of the sensors, the rain sensors and also the rain gauge. So the last two here are actually on the river basin. So this can be used. So you can see that, you can actually put out warning, yeah, or yellow warning and so on, so that people will know, the authorities will know when to do what. Yeah. So this is we built this into the community portal, right? So this is sorry, yeah. So this is built into the community portal. So this is project number one, and of course, on the onset of the project, one of the requirements for the sponsor from the Japanese government is that this project must be beneficial to the community. And at the end of the day, we actually provide all these systems to the local authorities for them to operate. And we provide training as well. So I think this is a very good example of a cyber physical system which we think of in the fourth industrial revolution. So this is a first project that I wanted to share. If I may, I want to quickly go on to the second project. The second project is on precision agriculture, helping our Malaysian cocoa farmers to increase their production. We have a spin-off company in the university who is in this business basically. So what I want to share is actually this part. So of course, this spin-off company does a number of things in the area of precision agriculture, from fabricating sensors, manufacturing them, right until the operations. So what I want to actually talk is actually the number 4 here, which is optimization of our national cocoa productions. So we work with our national cocoa board, who is in charge of, he is in charge of the entire national cocoa agenda. So we work with them. We go and look at what are the issues faced by the cocoa farmers and so on. So if you are, many of us love chocolate, but perhaps you have not, perhaps you have not seen a cocoa tree before. So this is how a cocoa tree will look like. This is the cocoa pods. Yeah, these are the cocoa fruits. And when it's ripe, when you take it, when you pluck it, when you harvest it, on the left-hand side is what you will see inside the cocoa fruit. Okay, so you see the cocoa. So you get your, after some processing, you get your chocolate from here, right? So we work with one of the plantation in one of the rural areas in Malaysia called Bagan Dato. Now, one of the key issues faced by the farmer is that because they don't have precise information on the soil moisture. And why this precise information is important? Because of fertilization, right? And a lot of times we found that farmers actually waste fertilization because they are not able to get good information on the groundwater. So they will just, put the fertilizer, at particular periods of time, even though it may not be required. So there's a lot of waste there. And of course, when you do manual soil tests, this takes some time, because they need to send it to the lab and come back. Okay, so a lot of cocoa planters, rely on best guesses, okay, or outdated data to treat the soil with fertilizers. And also another challenge is that because a lot of cocoa planters in Malaysia are actually the old people, the younger generations, do not want to get involved in this business anymore because it's very tough. So one of the key agenda that we also have is that we hope that with the use of technology, that will attract younger people to get involved in the business of agriculture. Right? So what we then do is that if you see this picture here, this is actually a probe. This is a multi-sensor soil probe, which is actually, I think it's about 1 meter in length. This is fully designed, developed, fabricated, and assembled by our R&D team. So you have so it's operated with the solar cell here. Solar cell, because in Malaysia we get a lot of sunshine, so this is fine. And you can see the data logger component here. This is the box here, which receives information from the sensors, which is planted down. So it looks like one very long stick. And the communication module is also in this board here, where it communicates back to the cocoa planters, center all the information that they need. And that can then be used to sort of communicate to a relay system to either switch on, turn on the fertigation system, or turn off. And this is something that is not very difficult. So what we do is that, so our engineers, what they do is that to help the cocoa planters, because these are senior people, right? They are not young people. So physical energy is a bit limited. So to make it easy to install this into the ground, we actually put this soil augers at one end. Okay, and when you actually push a button, you can just put it in. Okay, and we use advanced wireless technology. I can't recall what this team used, but we use this to actually connect with the remote farms, right? And just to give you an idea how this actually benefits by just deploying a few of these soil probes, just to give an idea how this will save cost for the farmers and make them more profitable, right? You can, of course, we do study on cocoa tree, palm oil tree. Why palm oil tree? Because we have a lot of palm oil here, but of course, rubber tree we have. But if we just focus on cocoa tree, so the fertilizer used basically is the NPK, right? NPK blue, and the amount required is actually 1 kilogram per tree. Right, 1 kilogram of fertilizer per tree, and within a hectare of a plantation, you can have about 1,100 cocoa trees. And of course, the price per kilo in Malaysian currency is 40, and you need 3 times a year. So the total cost is this is the current cost that cost the farmers, yeah, because they need to put it in 3 times a year, because they can't tell when is the best time to put and when not, right? So the total cost for 1 hectare area is about 132,000 ringgit. So this is maybe about maybe 40,000 USD per hectare of plantation. So when we made a bit of study with this system, if the planters actually deploy this system that we developed, it is a one-time cost, right? It is the system will cost them about 25,000 a year. And from 132,000, we are able to just help them to save more than half. So they will incur only 55,000, because we can tell them exactly when to do fertigation, right? Because they don't need to do 3 times a year. It depends highly on the soil moisture. Okay, and also so the irrigation cost reduced by more than half, and the manpower loading, because in order to put this fertilizer, you need manpower, right? So manpower can be reduced by up to 60%, right? So this is, just by by the researchers looking at how we can actually help the cocoa planters, we can actually help them, with very low cost, help them to save and help them to increase their profitability. So this is something which I think is very good for the cocoa farmers, right? Okay, so that's a bit short sharing on the cocoa, using technology to help our farmers. And lastly, I want to share, this is the most recent and the most recent project that we are doing, which is called facility management. It's called smart toilet. Okay, so this is the team. I'm part of this team as well. It's led by Dr. Kany Palace. Okay, so what we are looking at is that we are looking to help building management, especially because in Malaysia we have a lot of tall buildings, we have a lot of apartments, office complexes, and so on. And you see, most of the time, just to cut the story short from this slide, is that if you look at how the janitors operate, the janitors actually clean the toilet. You have a fixed amount of janitors coming in the morning. They clean the toilet, and periodically they will clean the toilet. Whether the toilets are being used or not, they will be there. They will sign their worksheet. Whether the toilet is used or not, they will still clean it, or they will do something or not do something, right? So that is something that we look at as a challenge. And we think that with technology, with this IoT and 4th IR technology, we can sort of optimize the work of the janitors and also the number of janitors required. Okay, and at the same time also, we will be able to provide real-time usage status of such facilities. Okay, so this is the entire architecture of the, so to summarize the entire thing, I'll show some pictures later on. To summarize the entire system, right? You have the, what we do is that we plant sonic sensors in the toilet, whether it's a sitting toilet or squatting toilet, they are the same. The usage information is then sent by your MQTT protocol or the HTTPS protocol into what we call, this is Open Innovation Platform. This is our own cloud. Okay, so this cloud belongs to our own group of telecom research and development, which will then serve the information to the mobile app. So if a user, you will know, before you go to the toilet, you will know whether it's occupied or not, right? And to the you can use it in the web app as well. Okay, so in the mobile app, you can give the toilet your user rating, whether you're happy with the toilet. You can know the occupancy status because we have sensors inside the toilet. And also, what is interesting is that there is an automatic scheduling system that we are developing to help building facilities management to schedule dynamically how many janitors you need, what time you need to clean, and so on, depending on which blocks of buildings and toilets. And best is that we have predictive maintenance. Okay. Now we know that if a toilet is being used more frequently, you probably need to replace certain equipment or parts quickly, right? So this is the entire concept of this this project, and this is how it works. So this is a toilet. This is the real installation that we do in my faculty building. We'll show you some real pictures later on. So you have, with each toilet cubicle, you have your Raspberry Pi as the processor somewhere, and you have some sensors here. We tried many sensors, so at the end we settled for ultrasonic sensor. Infrared sensor does not work, and we don't use any other optical sensor because this is toilet, right? So you can't use optical sensors. So at the end we settled for the ultrasonic sensors, and all this Raspberry Pi will be connected to a router, which will then be connected to the server. So the server may be in the cloud. Okay, so this is the what we call the screen design for the mobile app. The scheduling. web scheduling for the janitors. So we can schedule how many janitors at which floor, at which toilet, and so on. Right. This is the dashboard of all the toilets. Right? Okay. So this is the photo of the real equipment. So this is the box that we have in each toilet. So you can see all the cards will be here. The Raspberry Pis will all be slotted in this card. This is the fan. This is the power module. Okay, so what's inside this box? You can see this is so this was an empty box. So when you fill it up, this will be how it looks like. Okay, this is the communication module. These are all the Raspberry Pi here, and you have the power modules here. So this is locked up, closed up in a box like this, and installed on the ceiling of the toilet. This is of course the power switch, right? And we had to actually open up the roof. This is the air conditioning system of the toilet. So we have to do some modification and renovation and fit in all the wiring and the boxes, right? And this is the building which we are implementing it now. So this is the building of the well, this is my faculty building, Faculty of Computing and Informatics. So we have this sort of technology installed on all toilets on all 4 floors in this building here, and we are collecting data now. We are collecting data, and of course we are now trying to arrange for us to install at least some of the equipment in our headquarters. So this is the headquarters of Telecom Malaysia. This is our parent company. If you come to Malaysia, you come to KL, you will see this building here. It is a 55-story building. So yeah, we are trying to have it installed commercially and explore how we can actually sort of commercialize this effort. Why this is so important? Because you help the building facilities management, to optimize the operations of cleaning and of course to reduce costs. So this is a award-winning project. I think very recently we won the gold medal in the 2020 International Invention and Innovation Competition in Canada. In fact, we won the gold medal also last year for this project. Okay. So yeah, that's about what I want to share. Main point is that I tell my team that whatever research project that we do, should be very much oriented to solving, problems, real problems, society problems, or something that can benefit, organizations and businesses. And not only the research should stay in the lab, but it should be brought out to, to the real world to be used. So I guess that is what I
Any questions from participants' side?
Yeah, I'm happy to take any questions. If you have some idea you want to discuss or to collaborate, yeah, please feel free. Or you can reach me in the email then.
Yeah, you can collect some questions and then send it to Dr. Ho for any response later on.
Yes, sir.
On behalf of KCG College of Technology, I would like to thank Dr. Ho for his information. All the participants take away the technical insights shared today. Thank you so much, sir.
Thank you. I hope you enjoyed the talk.
Thank you, sir. Thank you. Really good. It's a touch of humanity. What you are
Sure,
saying
sir.
is that whatever you do has to
exactly.
be benefited to the society. The
Exactly.
research areas, that's a very good human approach. Really good. I think that's what everybody should follow, so that the research reaches the end user. We should use our technology and focus it for development for the common man.
Yeah, exactly.
In our country, we call Aam Aadmi.
All right. Okay.
So common man must get the benefit of that, because ultimately the science and technology advancements has to reach really good. And I really thank Professor for sharing your experience and sharing your time. Really, I am grateful to you. Thanks a lot.
My pleasure.
Thank
you.
Thank
Thank you.
Sir, can you share your slides so that it would benefit the participants? Actually,
Sure.
we are
Actually,
collecting all the slides.
Can. I have sent a link to Dr. Sambandan earlier on. I think it's there in the Dropbox, but I can send again.
Okay.
Yes, sir. Thank you. Thank you.
I request all the participants to fill the feedback form posted in the chat box, and it accept the response half an hour only. Okay. The next session will start exactly at 8 p.m. today, 8:30 p.m. today.
There will be a very last session for this series. Professor Addis from Gulf University, Ontario, Canada, is talking on artificial intelligence and cyber security. It will be a wonderful talk. Everybody, we request all attendees to gather at 8:30 p.m. Because of the time zone difference, we were unable to organize before 5 o'clock, because she was wanting at only after 11 a.m. from their time, local time, Toronto. So that is coming to 8:30 p.m. here. So you bear with us, and then this is the last lecture of this series. I hope we will support the speaker with the large number of attendees. Thank you.